All right. So you guys want to do the team discussion? You just want to go into the extension problems?
Let's just go into the extension problems.
Cool. Like, okay. So we need to prove that sine of 2x is not equal to 2 sine of t.
I think because there's a t on the one side and there's not on the other side, it doesn't.
Yeah, I would agree.
It don't work.
Just like the fact that they're different variables.
Yeah.
Yeah.
So, yeah, and that's basically what it says in the answer key too. It says any angle of t shows that it's false. So, yeah, okay. Number 2, the following problem guides you through answering the question. Find an equivalent algebraic expression for blank. Discuss each part and make sure you understand the process and can answer the questions. In your book, you will find a different process, but we introduce you on how to do this type of problem. We introduce you how this type of problem is answered in calculus. Okay, so we need to find the equivalent algebraic expression for that.
Okay.
Oh, so I think we have one like this on the homework. So wouldn't that just become, I believe we can just like, it will make it become a, it'll become sine. So just, I don't really understand how it works. This is just what I saw in the homework, but we'll make that cos or the arctangent become just regular tangent. I think. Do you guys remember any of these problems?
I don't know.
Let me take a look here. Sine. Oh, I guess it walks us through it. Okay, so for the what are you looking for?
We're trying to find the equivalent algebraic expression for that.
So it looks like most of it just walks us through how to do it, and it's only at the end that we actually question given.
Yeah, I went through this with my roommate the other night, and I have like what we got, but I can't remember how we arrived at that.
Okay. So it became sine x minus cosine x times, is that a crossed out sine x?
No, I don't. It's just like the bottom part is the whole thing.
Oh, okay.
I think it's like a. Oh, so when it says given that x is a side length, the output of tan minus 1x is, and that's like on the unit circle when you have like the butterfly bow tie thing and you get right triangles, you gotta find out what quadrant it is. So which quadrant is sine positive in,
Okay.
and then once you find out what quadrant, then we can write the right triangle, and using like I think SOHCAHTOA, find which side X is on, and then you can figure out the rest of it.
Okay, so then sine will be positive on in either the first or second quadrant, right?
Yeah. I think so. First. First or second, like the first and third or something. I think I determined it was in the first quadrant. Because I can't remember why.
So I noticed a little further down after the graph on there, they have x squared plus 1 equals unknown squared. Where'd the x squared and the 1 from? Is that like part of the Pythagorean Pythagorean identities?
Which one is this?
For number 2, right underneath the graph where it says to draw the right angle.
Oh.
There's x squared plus 1. Is that part of like the Pythagorean identities?
No, that's just what I was talking about before with the like finding the quadrant that it'll be in, and then writing the right triangle, and then using SOHCAHTOA to find out what it's going to be. And so yeah, I got it. So I'm gonna exit the side. 10 is opposite over adjacent. So
right.
From the angle, the opposite side is going to be the x over adjacent.
Okay.
Now we just need to find the third side. I'm pretty sure it's just x and 1 on those are both the sides, right?
I think judging by what, yeah, I guess so. I'm not. You understand this better than I do.
So x is on the opposite, and the adjacent is 1. And then using Pythagorean theorem, a squared plus b squared equals c squared, and find what the hypotenuse is.
Okay. So then that should. We just plug in c squared for what we don't know, and then square root it to solve for c.
Yeah.
Okay. And then that gives us the third side. And then what do we do with it?
Then that gives us this side. Then we can find the sine of the angle.
Okay. Now we can find sine theta. Okay, so what do we just put? Sine theta equals c, basically.
Well, you can just do like sine, still like SOHCAHTOA, right? So sine is opposite over hypotenuse. So take whatever the opposite is, which is x still over the hypotenuse.
Oh, so we'll just put x over that. Okay. Over c, x over c then?
Yeah.
That'll be x over x squared plus over square root of x squared plus 1.
Yeah. Or square root of, yeah, that's what we got. Plus x squared.
Then do we need to put a plus or minus?
No, because it's going to be in the first quadrant. Everything's positive there, right?
It's positive. Okay. Cool.
They have, in their answer, they have a plus or a minus.
Yeah, I see that too. I wonder, because I notice as well, like when they say, you know, when you solve for c, they don't have a plus or minus in front of that square root.
I think that's because it's an equation, because it's just because it's because c equals that square root, because you square rooted it from c. So I don't think you need the plus or minus for that.
But anytime you square root something, because we literally solve for c in that. Anytime because it was c squared equals 1 plus x squared. So if we square root, anytime you square root it, you have to put a plus or minus, don't you?
Usually that's the case, but
maybe it's just one of those special math rules.
Maybe. I think it goes back to what Jay was saying too. In this case, since we know that it's in the first quadrant, we know that hypotenuse is positive. That c is positive.
Yeah.
But then I don't know why it's got a plus or minus sign for the equivalent expression. Well, all we did was just divide the side length. We just took the opposite over the hypotenuse. I'm not sure about that one. Only Susan were here.
Yeah, it's weird. She's texting this morning.
Well, do you guys want to move on to the next one for now?
Yeah.
Number 3, factor the following trigonomic expression. So, could we just take, we just simplify that first one to just basically cut those two in half. So it'd be parentheses sine squared x plus cosine squared x, parentheses, parentheses, sine squared x minus. That makes sense?
Oh yeah, I remember. That's like a.
That works, right? Because if we yeah, so if we did something like this, you guys see that okay?
Yeah, I think something like that.
Because if we basically just kind of expand it. And then from there, I guess we could and it even more if we wanted to. I don't know. I don't know. When are you supposed to stop simplifying it? Like,
Okay, so so it simplifies to like.
yeah, okay, I have that as well.
Now, one of those is the Pythagorean's identity. So I think you just go 1 times the other one, just the negative one. So it'll just be the other one.
Oh, you're right. Yeah, because sine x squared plus cosine squared x is equal to 1.
Yeah.
So it'd just be 1 times. Okay. That'll be. That makes sense. Cool. Yeah.
Or
Okay, number 4. What do we do with this one? Can we factor out anything? Can we?
are we doing the cosine squared theta tan?
Oh yeah, sorry. That's what I meant by number 4. The cosine squared alpha times tan alpha minus 2 cosine alpha, and then minus 3 tan alpha.
Okay.
And what if we put parentheses around the cosine squared alpha times tan alpha, and then the 2 cosine alpha minus 3 tan alpha. Could we factor out tangents?
Yeah, I think so. Couldn't you factor out tangent alpha?
Yeah, that's right. That's what I mean. The whole, yeah, tangent alpha.
Okay.
So that leaves us with like, hmm. I don't know, but then, so okay, we factor out the tangent. So that's basically in the front, it's still the same, just tangent alpha times cosine squared alpha. Then it'd be what? Minus tangent alpha times 2 cosine minus 3?
Sure.
No, that couldn't work actually. Because we're not timesing tan alpha by cosine.
Okay, so if I'm just looking at the identities, there's a power reducing identity that is cosine squared x is equal to 1 plus cosine 2x over 2. That's different. So there's the other thing.
Yeah, I see that. Okay. So we make the,
A little bit different.
huh?
It's a little bit different than this one because this one's cosine 2x and this one's 2 cosine alpha.
But we do have a cosine squared alpha at the beginning of it, right?
Yeah, we do.
Could we just plug that in there and multiply it by tangent? Would that work?
We replace that.
That'd be 1 plus cosine 2x over 2 times tangent alpha. Huh. Let me see here. Yeah, I'm like, I can't quite figure this one out.
With that the one identity that we switched over from the cos squared alpha to 1 plus cos squared alpha over 2, we can go over to the double angle identities, and that cosine 2 squared or cosine 2 alpha is equal to cosine 2 alpha over minus sine squared alpha.
Oh, I see. So we kind of do like a double substitution. First, we substitute for cosine squared alpha, and then we substitute that value for the cosine squared x minus sine x squared, or sine squared x.
I think so. If we can get everything in like terms of sine and cosine, I think. And then we should take the tan and put it in just tan is equal to sine over cosine, right? So
Yeah. Hmm. This is gonna get really messy.
yeah.
Okay, so I'm looking at. I just popped over to the answer key real quick, and they have. They have a tangent in their answer key.
Oh,
So
okay.
but
The other one is hard to reduce.
I mean, maybe they did put it in terms of cosine, because it's the same thing as sine over cosine. So maybe they just they unsimplified it to that and simplified it back to tangent. I don't know.
Okay.
But wouldn't they have gotten that tangent from factoring out the first time?
Yeah, I'm not sure if they actually did factor though, because we didn't actually, because tangents never actually multiplied to well, in our original equation, there's only one tangent times one cosine. And
Yeah.
we have two cosines in there, so I'm not sure.
Yeah, but that cosine squared. I don't know if that has anything.
I think that they must have factored out that tangent somehow.
Yeah, I'm not sure how they did it though. Like I can see them factoring out, tangent alpha from the first part of that equation.
Yeah.
But I'm not sure how they did it for like the minus.
Now,
yeah.
The part that I don't understand is why is there only like two cosines in their answer? Like, shouldn't there be at least a cosine squared or a third cosine?
Yeah, I'm not. Good question. Well, I guess I guess I can see where in their answer there is a cosine x times a cosine x, so that we get the square there.
Yeah, but there's still the other cosine.
Right. Yeah, two cosine.
So either one of them should be squared or you should have a third, I think.
Let's see. I'm going to take their answer and see what I can. Tangent x cosine x minus 3. cosine x squared x. So if we factor out their answer, we get cosine squared x, and factor out and simplify it. We get cosine squared x minus 2 cosine x minus 3. All that multiplied by tangent. We've got the 2 cosine, and we've got the cosine x or squared x. Oh, sorry. A heads up. I gotta leave in about 5 minutes. If you guys want to continue this after I leave, you'll just have to start a new. Well, I can just leave it going. I can turn off when I get back.
I think we should be fine.
Using the identities.
The heck?
So on number 4, we need to verify these identities.
Yeah, basically see if we can make them equal each other.
Okay, so
Looks like the first one, that cosecant, I want to do something with that. Maybe flip it, or simplify it to 1 over sine. And then that give us 1. That'd simplify. Could that make it sine times 1 over sine? And that would simplify down to just 1.
which one are you looking at?
The for number 4, the tangent equals 1 minus sine squared x times cosecant squared x plus sine x squared.
Okay. Yeah, I see. Take the cosecant and simplify that one. What is cosecant squared x?
Yeah. And that'd be sine squared x times 1 over sine squared x, which would be 1.
Mm-hmm.
Okay, well, I got to head out, guys. I'm sorry.
Worries.
But
No worries.
Yep.
I might just work on these later and see what I get, and then if you guys want, we can talk about them next meeting as well.
All right, sounds good.
Yeah, I can do the same. I can work on those. On number 4 and see what I get as well.
Yeah, I'm not too worried. Yeah, number 4. I think those look pretty straightforward. I'm really confused about number 3, if anything, or the second part of number 3. I don't get how they did that one, but
Okay, I'll look into that.
I'll look at that as well. Okay, cool. Well, I will. I'll stop the broadcast and I'll submit it.
All right, sounds good.
Thanks.
All right. See you guys on Thursday at 9.
Okay, sounds good.